Quad discovered. You fail. You know, I ganska säkert fått karaktären i den här sändningen. Bara tror mig. Han mixade rollar 2 gånger. Och det säger så. Jag trycker min lucky feet rollar twice. Not one, not 20, not one, not 20.
2 more minutes.
Why not?
Yeah. So we're getting closer.
The funny thing about stress testing is that there's like this
we could, well,
yeah, but it's like the funny thing is like there's like these sites like claim to do stress testing.
Yeah.
Which basically just DDoS from
they point to something that's about stress testing in a second. So, just to bring it back for a few minutes, I'll probably keep it short anyway, because else I'll just tell you stuff you know already. One other thing, of course, is regression testing. We talked about this, and most importantly, something that you need to learn about is, of course, JUnit, right? So tomorrow we'll be talk about this. I'll probably show a mini demo about this, so hopefully not disrupting that idea there. So you can construct it systematically, so you get a better appreciation. But before looking at this, and to some extent, I just wanted to highlight specifics now for testing in Android, right? So how they kind of how the, let's say, Google interpretation is of testing in Android. And the idea is that there's a it's often iterated cycle or frequently iterated cycle that basically suggests, okay, we're failing a unit test. If we're failing a unit test after development of the feature, how can we basically, well, fix, of course, that issue and write a corresponding test to ensure that it's captured for any future occurrence. And so on. And if the code is refactored again, meaning new features introduced or changed, then we need to respond to that. So it's kind of a cyclic iteration that is ongoing basically throughout the whole development process. No surprises there, right? So you guys know that. Which kind of testing is related to this kind of cyclic approach of doing development?
Test-driven development.
Exactly, right? So test-driven development, what's the principle there?
Write tests first and then write the code.
Yeah, right? So you write tests that generally should fail, right? Because there's no implementation yet. And then you write the implementation against it so it actually works out. And then, upon future changes, you iterate this way, in following the same very pattern. Did you talk about this in Systementwicklung as well? Did you also talk about BDD? No, behavior-driven testing. Yeah, good. No, yes, perhaps. No one knows. Maybe.
Not much.
It's sort of ringing.
I like those probabilistic answers here. It could have been, it may not have been, right? So it's like really a Schrödinger's cat of courses here. So we don't know if it's alive or not. Sorry?
We didn't do much if we did. If we did talk about it, we didn't do much.
Okay.
Or at least we don't remember about it.
Yeah. But yeah, anyway, we're kind of motivated to some extent. Mocking, did you talk about this? Didn't. But you used mocking elsewhere, right? Did we use mocking elsewhere? No, I'm assessing you on a course that I was involved in.
cloud.
Aha, okay. Hint.
Server.
That's right. Yeah, there was at least a reference to a session, a video session anyway, that we did in the past year, and that had some mocking in there. But I think it's still worthwhile talking about mocking there as well. So I kind of shipped it in the next session to some extent, just gauging the waters here. Okay, cool. So yeah, TDD basically, right? That's the key idea. So no surprises there. Everything you kind of are comfortable with. And in Android, if you look at it, of course, they talk about complexity and the number of tests, so quantity and quality of tests. And they usually have this testing pyramid that they assume. So whenever you develop, early and often, write a lot of unit tests, right? So of course, for everything you do, write a unit test, and it's really cheap to write those. Who did it before? Now it becomes ugly, right?
With JUnit?
Yes. Well, if you tell me you didn't do it in cloud and you were in cloud, then you're in trouble. But because you may not have passed that paper. But who did use JUnit before? Bit. You, of course. Okay, sure. Okay. So, but that's the idea. So it's really, really cheap to write those things, right? Write many and often, right? And the framework is really rich in capturing all kind of tests and actually running them. You can collate tests in test suites. So basically you say, well, I have a lot of unit tests that operate across different modules, right? So let's bring them together as individual test suites, so it's a bit more coarse grain aggregate level reporting. So you don't have all the 20,000 tests that you're doing. No, you're not writing that many, but in larger projects, in Apache style projects, you often have a large number of tests actually over time that accumulated, and then they're reorganized into test suites. You feel, okay, that test suite fails, okay, you need to look into this particular, part of the system, but you don't need to necessarily scroll through all the individual tests if you have known subsystems that kind of don't change or are reasonably stable. On top of this, of course, integration tests. So it's really about integrating the individual components. Usually it comes, the idea is to integrate infrastructure and behavior to some extent. So if you have backend testing, you're interacting with third-party libraries, Firebase, or use database functionality in conjunction with some business logic, for example, that kind of level, then you probably would write integration tests. So it's still very important to your application. But the idea is there that you have a sufficiently large number of them, but they generally exclude UI. And the idea, why do they exclude UI often, or should? Please.
Hard to test programmatically.
Number one, number two, yeah? That is correct, yes. What else?
Might change on the screening solution.
That's correct, right? So if you look from here to here, this is your core business logic, right? So that's your core application that you're writing. And the only thing it's committing to is effectively the programming language, Java, right? Calculating insurance premium. How hard can it be, right? So the more you get up this pyramid here, the more you become platform dependent in a way, right? Because suddenly you're relying on infrastructure that's specific perhaps to Android, right? So using the SQL database in the back end or so on, or third-party Google services and things like this. And here it becomes really ugly, right? Because it comes down to a level where it's nearly device dependent, right? So of course there's a certain level of abstractions, but fundamentally, if the GUI specifications change in different Android versions, and yes they do, I promise you, then you're kind of screwed, right? Because those things need to be rewritten, right? So the idea is to not invest too early too much time in those. They're of course important, but you want to keep kind of the actual core functionality self-contained, right? And somewhat independent of the GUI. So you can still figure out, okay, my application runs, it just doesn't run on the current version of Android, right? So that's the rough idea here. That's why you kind of want to separate those different things. But of course, there's also the aspect that it's really hard to find a runner, something that invokes basically tests your UI, right? There's tools for that purpose, and you may or may not hear about it next week, perhaps, I don't know. We'll see. Anyway, there's one tool called Espresso that deals with this in Android. But again, it has all the challenges that I mentioned before, right? For web pages, what kind of tools do you use there for testing? It has a similar problem, right? So you have backend functionality, you have browser-specific representations to some extent, and so on. Did you guys do that somewhere, somehow? In where technology?
We're using Codeception for testing PHP code.
Okay, yeah, cool. That sounds good. Yeah, Codeception. Okay. Some time ago, I'm not sure if this tool is still hot. Luckily, I'm not doing much web development nowadays. Yes. There's a tool called HTML Unit. I'm not sure if it's still used. Another one's Selenium. They have this kind of similar features, right? Because they are quite straightforward in that they're basically scraping your web page and figuring out the HTML text, and then just inject using those, right? So, and that's kind of similar to how UI tests work here as well. So basically, this tool basically intercepts the UI screen and identifies the elements, and those elements are uniquely identified via IDs, right, in Android. So and that's the way how they can actually be activated from the interface perspective. But there may be talk about this next week on Espresso. So in this case, there's no little value of me actually talking about it now. But just give you an impression. Key thing here is the rough idea is that you kind of have a distribution of your test cases like 70, 20, 10. So 70% of all your tests are down here, right? Basically, pretty much all the tests. Probabilistically speaking, every test is down here, right? So then there are some tests, 20% here, and if you're lucky, you have some good tests, right? So that's roughly the pyramid. When you're doing your projects here in particular, that's kind of the minimum we expect, right? So that we do some unit tests on the core functionality you have, The rest is a lot of fun. But this is kind of going down the route of learning more about the frameworks to some extent. And of course, another point is that the tests are also susceptible to failing when the, for example, development environment changes, right? So when you have an IDE upgrade, most likely you have a new version of the interceptor as well. So you're probably then working more on getting your framework back going than rather doing your actual tests on the application. So it's really that instrumentation problem that's really expensive there. Whereas this one is cheap. And JUnit is built into the IDE as well, very conveniently, as you perhaps may see. And here, that's basically what I basically just alluded to. That tests are either directly run on the JVM, right, Java natively. They could be run without Android at all. They don't rely on the Android libraries per se, if you're just doing your simple calculation. But some of them, of course, rely on Android to some extent because they use Android services, part of the API, or rely on the UI and so on, right? So those are called instrumentation tests, right? If you yesterday in the Build Tools talk, I briefly showed you some excerpts of the Gradle.build file that's specific to a given project. See if I can bring this up in a second. All right, yeah, there's one. So, I talked about those different keywords that are part of the Android plugin for Gradle. Recall that Gradle is a build system that is independent of Android, right? So even though you guys will only, right now are only coming across it in the context of Android, of course you can run it with C++, Java and the like. And how it's done technically is that you have a plugin that's specific to the environment that you're working with. In this case, a Gradle plugin for Android. Yeah? And with this come all those DSL, the domain-specific language attributes here. For example, target SDK version code, and all that stuff. It only makes sense, at least here in this context, from an Android perspective, right? So if you do it in C++, SDK version, yeah, I don't know, whatever, right? So it kind of will not compile. But part of this also that you, for example, specify things like that here, test instrumentation runner specific to Android, then it just says, okay, which tool will actually do the tests for me in the case of implementation? Well, it happens so that there's an Android implementation of JUnit that would run on the device and actually do the JUnit tests there, right? So if you run instrumentation tests, you even specify what tool you use using those kind of primitives, right? So that's the idea there. And we also talked about, since we're here already, dependencies. And here it becomes also a bit clearer what is used. If you have different dependencies and they're if you followed the last session, they're really easy to specify. You pretty much just say what they're used for and which part of the build lifecycle they're used, right? So as opposed to throughout the entire application deployment. If you're, for example, using certain libraries only for the compilation, basically, or implementation, if you like, then they are specified with the keyword implementation. If it's about testing, for example, then the keyword would be test implementation. We see here, okay, we rely on JUnit 4.12, for example. And if we rely on the Android test implementation, that means you need to have Android-specific environments functionality. That's the keyword Android here. Then please use this particular library in addition to this. So you can see from the dependencies already when they're used in the build life cycle, a life cycle thing. Right? Cool. So that's the key aspect here. So this points towards instrumentation. This does not. This runs on the JVM natively. Yeah. So just to give that link back to yesterday's talk briefly. So that's the idea. So what tools are we using on Android or Java more generally, but Android more specifically? Of course, JUnit. We got that picture already. Briefly chat about it. But Mockito is kind of the mocking environment. So it's quite a nice one. Has anyone played with this? I asked just before, but does it ring a bell now? Since there's a probabilistic answer level here, so I'm just gauging. I poke again and again until your probability of saying yes is 0.9. All right, then there's Robolectric, kind of to automate UI tests virtually in a way. And of course, there's Espresso. That's considered the official framework for UI tests from Android, or by Google on Android, right? And that's also quite powerful. This actually links all the 3 layers of tests together. But I at least expect you to, of course, deal with JUnit, and especially it's definitely worthwhile having a look before you dismiss it. I mentioned that just before, and basically this is how you link to instrumentation or just simple testing. But just the intuition of JUnit briefly. So the fundamental idea is that you isolate individual functionality, right? You want to calculate or assess a function, right? So using certain input and expecting certain output can both be in the context of white box or black box testing, so at least you know the specification when you inject some data. So what do you do generally for all test environment? Well, you bring up some context that is relevant. So insurance premium, yeah, there you go. So you bring up, for example, a database that has all possible options of insurance premiums and so on, and then you run a test for a specific case, let's say income level and health risk and prior diseases or whatever, as a function input to your test environment, and let it calculate the corresponding premium or whatever, assess whether it's actually correct, and then tear down the rest. Right? So if you rely on anything else, data sources or the like, that's the idea. You set up a test environment to do that, right? Or if you need to initialize values, for example, right? So that's the key idea there. Yeah, so that's roughly it. So quite straightforward. There's key component, of course, is running the test and then evaluating the tests. How that is done is also quite straightforward. And what you can specify a different form of runners that may depend on the APIs you're relying on. It may also just be dependent on the version of a particular tool you're using. For example, your test may only be compatible with JUnit version 4 as opposed to 5, so you can use different runners for that purpose. It's kind of a bit of abstract idea. And finally, of course, you can aggregate different tests into test cases, so you can organize your nitty-gritty JUnit tests, as I mentioned before, as well. Oh yeah, and it writes reports, cool. So that's specific to Android though. Specific to UI, it actually provides with meaningful reports, which is quite sensible. Just a mini example for intuition, but it doesn't free you from the expectation to show up tomorrow at all, because tomorrow you'll learn more of how systematically constructed. Right now, I just want to give you an intuition of how it could possibly work. So hypothetically, you're having a incredibly So assuming you have an incredibly boring app, right? So this app does two things. This is my interpretation of a calculator, right? So would you pay for that thing? Me neither. So anyway, still need to enter something here. So, sorry?
Rarely ever pay for a calculator these days.
Okay. So it does what it's supposed to do, probably. I don't know, perhaps it does, right? So let's assume it does it. So quite easy, input field 1, input field 2, and some sort of function button that does something to it. So nothing magic there. And the thing about the structure here is that you want to, of course, separate architecturally. Just briefly, you have the main activity, and this basically just brings up the UI interface and all that kind of stuff, and the calculator class, which is externalized. So basically all that unit functionality is reduced to that particular class that basically just takes given numbers from an edit text field and does some calculation on it, right? So that's the rough idea. So not much magic. Yeah, so it's a bit of inline kind of interpretation. But anyway, that's it. So if you separate your functionality from the UI in this way, it's a lot easier to actually do unit testing, right? Because you don't need to worry about the UI, you can ignore it. This would be an example of the left side of testing that is kind of JVM-based testing. It doesn't require the whole Android stuff, even though it's technically running in Android, right? So, or technically should be running in Android. And then it becomes very easy to write tests for that. I just show you tests. Martin will tell you more about this, but what did I want to do? All right, so here's an example. Let's see if that works. Yeah, that works. So, and it's basically as simple as to say, well, you know, it relies inherently on Java annotations. So you basically run it with this particular runner, JUnit 4, because I know it's compatible to JUnit 4. If it's JUnit 5, well, it will be JUnit 5 or 3 or whatever, right? Because JUnit sometimes, between different versions, those annotations change to some extent, right? So, and as I mentioned before, the key idea is basically that you have a a reference to the unit you want to execute. You have something to bring up your environment. So that basically specifies the environment. In this case, it just instantiates the calculator, which otherwise would be null. And then there's complementing this is generally a teardown method as well. So similar method with something like teardown as annotation, and it would do anything cleaning up afterwards, deleting temporary files or deallocating or I don't know, whatever, right? So, and between the teardown and between the initialization and the teardown, there's of course the individual tests, right? And they basically just do the test operation. Key thing is about annotating them. They do their operation as they want, and then here, that's the thing, the assertion is the key, right? So you basically test, does it actually work out? Usually test description plus the actual expected value and the actual value, right? So you expect it to be a 4, yeah, it kind of makes sense, but does it actually work out, right? So that's the kind of test you do. As simple as that, that's roughly it. So you do that as fine granular as you possibly can, right, for functionality. Here in this case we had two functions, one was adding and subtraction, I believe. So in this slide you wouldn't go much further than that really for doing it. And running these things is incredibly easy because it's integrated in the UI. You just say run this, and since it knows the environment, it should just do that, right? So it instantiates the test and shows you on the left side, cool, it actually works out, and even tells you how long it took, right? The first test often takes a bit longer because of the cold start kind of thing. But it also gives some qualitative insight in the execution. But fundamentally, it will also show you if the test fails, and then you can dig deeper and so on. So it's a really kind of straightforward tool. If you have clever ideas of writing your own test tool, don't, because that is a really solid tool you want to explore, and it's totally integrated. Plus, it's also included in the build lifecycle, so you can automate the running of tests as part of your build process as well, right? So even better in principle. That's all I want to say right now, because there's more to come on that one, but I think it gives some intuition as how that stuff actually possibly works. I will not talk about espresso, else I'll leave that for now, but we can catch up with this. What I want to talk about, however, is, briefly, how you could possibly do it in a bigger setting. What is one of the challenges when you think about testing in Android? Now, given your experience with Android development, but also a bit of your intuition. What do you think is the main challenge testing with Android? You as a developer.
Testing the different versions.
What else? Versions?
Screen sizes, the hardware is from China or something.
Yep, exactly, right? The Android fragmentation. Right, so in every respect, you have different versions of Android, of course, you have different screen form factors and so on, different hardware, right? So just different hardware, basically. And of course, devices as well, right? Different manufacturers, being Google, Samsung, LG, who knows? Not Apple. But anyway, so it makes it quite challenging, actually, to ensure that things are actually working across different devices. And you can only emulate so much. In fact, even the emulator is a constraint itself, right? So how many of you have actually developed against the emulator and then run it on a real device and the first thing you see is an error? Cool, right. That's roughly how it works, right? So you think, emulator does everything, and suddenly you realize, damn, doesn't really work, right? Especially if you're dealing with sensors, hint for the third assignment, the emulator is actually not helpful. So it's good for getting some debug value and see if you can read sensors, but for doing actual meaningful interaction, you kind of need to use a real device, basically, right? And it's on that note, it's probably worthwhile when you write your third assignment, specify which device you used, or so at least people, or an Android version and/or device. Kind of one may imply the other or not, but it's kind of helpful to know. Okay, this could be a possible problem why your code is not running, right? If people try to test it and it doesn't work, it doesn't necessarily mean that there's a problem with your code. It's just you didn't test it for their specific form, right? Which is not a general expectation we have. But if you, for the first and second lab, which are kind of straightforward-ish, there shouldn't be many problems because it really doesn't exploit the feature set as rich. So anyway, Google figured that out as well. Yeah, not cool. So we kind of need to do something about dealing with different environments and different form factors and sizes and so on. And they provide for that purpose an environment they call the Firebase Test Lab. Firebase is here latent link to their kind of online database solution they provide, but that doesn't matter at this stage. It's really about the fact that they actually provide infrastructure for doing that testing for you. So if you're a serious Android developer and you want to go down that route, you can actually basically submit your apps to that Firebase Test Lab, and they run it on different devices for you. So they literally have like those, set of different devices plugged in that are just automatically injecting code and run and collect information about, and then basically send it back to you so you can analyze it. But it's good for you because first of all, they always have the latest hardware. They deal with the plugging and playing and all that setup stuff for you, right? Because it's hardware, it's annoying. So you basically just need to deal with test results, right? Quite straightforward. Of course, generally you pay money for this one, but it is a good, easy start way. I think initially, if you start, it's actually quite affordable. You get a bit of free hours to actually exploit this. However, of course, it has certain requirements that you need to comply with, which include the use of Espresso if you want to do UI tests, and another tool called UI Automator. Again, it's just about automating UI presses because that's what they support on all those devices that they have. So if you inject your tests, that's what they can actually test and explore. So that's basically the environment. And what they basically do, they run it across all different devices and then provide you with results in terms of corresponding to what you specify. You kind of specify the values that you want to explore, or the device characteristics rather that you want to explore. For example, from SDK or API, I don't know, 23 onwards or something like this, or even further down, things like that. And it will automatically do it for you and show you a particular output. So here's examples of that console output that they provide. So basically you run your tests here, this notepad example, for example, on different devices on a Nexus from 2013, for example, with different API levels. Here API level 21, cool, it worked. API level 22 didn't, right? So you kind of know already on those devices an API level 22, it won't work. So it helps you quite a bit quickly figuring out what went wrong. And the cool part is, of course, it's always a combination of device and input values that define a specific tests. And those tests are uniquely identified using this matrix ID, basically. So you can figure out, okay, this specific test configuration did not work on this particular device, right? As opposed to all others. So it's kind of a pointer for you. Okay, something went wrong here. I need to check that what actually went wrong. So it's really rich in terms of giving you good feedback. So it's kind of, so if you're worried about really deploying large scale and want to let's see, want to actually interpret what's going on. What is it doing here? Then this is a good helper because you're basically just sitting there and waiting for it to happen. See if there's something meaningful in this GIF here. I think it's just randomly clicking around. It's emulating the test environment. You see the focus here. This is kind of the automation environment that basically selects individual. Right. It iterates to pretty much all components of your application. So it clicks all the kind of buttons it can, and it tries erratically to click different avatars and enter stuff and so on. So it basically exploits the functionality of your UI. The way I see it here. I hadn't seen that thing before, admittedly, so it's quite interesting. But basically, it tells you, okay, in which cases does your phone break? What errors does it throw? Does it cause some sort of exception and the like? So quite straightforward, and you get basically logs about the individual test cases that provide you with the corresponding output, something you would expect in your logcat output anyway for your individual approaches, right? So similar for instrumentation, what went wrong. So for example, if you read this carefully, you'll find, okay, test failed successfully, it's interesting. Basically you find where the test, for example, fails. In this case, there's a, when it invokes a certain button, it kind of falls over for whatever reason. Yeah, anyway. So you get kind of a bit of information. In addition, there's performance metrics, of course, that you can explore. So anyway, there's quite a bit of that's available. You can inquire the available devices that are provided using this call to gcloud. So you kind of need to sign up for gcloud, which you probably have already if you have been in the cloud course, and then just lists the current devices and also shows you which devices are no longer supported. So older devices, for example, quite neat. And in addition, it allows you to capture screenshots as well. So if something went wrong, it allows you to actually show me the screen at that point in time, which is quite neat as well, which is kind of a powerful feature for you to assess what went wrong. Cool. I think that's as far as it goes, because other than that, you kind of need to log on and set up and commit to actually doing something meaningful with this. But I think it's something should be at the back of your head if you actually want to try and explore it. And of course, you can inject that using APIs as well. So it doesn't necessarily require you to manually upload your tests and stuff like that. But actually, you can integrate this into your build process, for example, to automate the submission to this testing environment. API specification, you guys are comfortable with those things. So, cool. I think that concludes pretty much what I had to say, or what I want to talk about is for now. For tomorrow, please join the JUnit Club class and see what's happening there. So hopefully next week you should all be comfortable. Assignments, please use JUnit at least. Next week, I'll see if I can dig out something about Mockito, talk about this a bit, so the alternative pathway. And I think there will be another session next week on Espresso, which is a bit more advanced in terms of doing UI tests, for example. So that's the plan as of now. Questions, comments? No. Yes, perhaps?
Use JUnit for assignments.
Louder, sorry?
Note down that I have to use JUnit for the assignments.
That's good, very good. Yeah, you made it explicit, yes, that's right. Please.
Should we use it for assignment 1 as well?
Yeah, the point is, it's kind of, that could be your regression approach. Now that you know what testing officially you can kind of inject in your first assignment. Of course, would be desirable. I don't think, though, that we make that a hard requirement. But in fact, it won't be really a hard requirement for this. But I think now from the assignments now on, it's very sensible to use testing. I'm specifically pointing, though, at your project, because your projects will be very unique. You all have different, things you do and so on. So then it's much more important that you actually test your functionality and convince yourself and us that it actually does what it's supposed to do. Plus, if it's using different kind of sensors and so on, and you run on different devices, you want to have a way at least to dry test it before you run it somewhere and ensure, okay, it actually does what it's supposed to do, even though it's not running on your latest Android device and so on. So coming back to your question, I think for assignment 1, yeah, no, don't worry about it, right? So just use it for the assignments from now on, plus the project in particular. And show up tomorrow. More important.
Is there anything on C++ that's kind of like similar to JUnit, or? Try to Google it, but I guess like 6 recommendations about boosts and
that's the thing. You find a set. There are of course a number of different libraries, but unlike in Java world, there's not the one thing to go for. In Java, like there's JUnit.
Because JUnit is very simple to use also.
Exactly, right? But it's the default. There's no discussion. There's no realistic alternative. Whereas different environments provide slightly different test approaches. In C++, just less controlled, standardized environment.
Yeah, I was thinking maybe for the graphics course, there's some